Okay, welcome back. We are on page 129. This is activity 1. We're in module 1, topic 3. We are on lesson 2 and here in activity 1. Adding and subtracting decimals. So it says when you add and subtract decimals, it is important to align the digits in like place values. Let's consider adding decimals. Before we do that, take note. In a decimal, a trailing zero is any zero that appears to the right of both the decimal point and every digit other than 0. So we'll talk about that as we go through here, what a trailing 0 looks like. Okay, so the worked example looks like we have some decimal numbers that we're adding together. It says before calculating the sum, estimate the answer so you know the approximate sum. So it looks like they estimated to the nearest whole number. So 3 and 421 thousandths. The 4 says to keep that a 3. 9 and 5/10. So the 5 says make that 9 a 10. 12 and 85 hundredths. So if we're rounding to the nearest whole number, we can look at the 2, or we can actually think about the number as the 12. So the 8 says to make this number 1 higher, which means the 2 would become a 3. So 13. We can also think about it as the 12. The 12 becomes a 13. Then when you add those up, you get 26. So we know that our actual answer should be somewhere around 26. The worked example continues, saying to calculate the exact sum, line up the decimals so that like place values are in the same column. You can insert trailing zeros to help you align the numbers in the correct place value column. So when they wrote this, like, let me write it, I'll write it myself here. So 3 and 421 thousandths, 9 and 5/10. So the decimal point has to stay in line. So the 9 goes in front of the decimal point to the left, and the 5 is to the right. 12 and 85 hundredths. So here's the decimal point. So the 12 is going to go here, and then the 85 afterwards. Now, it can be kind of hard to add that up because I have these gaps. So the number that had the greatest number of non-zero digits showing after the decimal point was the first one, 3 digits, the thousandths place. So if we can just put zeros here, add these trailing zeros, and make that in the thousandths place, then we can keep our columns nice and lined up. Like they did here, they showed it in blue. So I just wanted to show you what it kind of looks like when you do it. The estimate of 26 and the actual sum of 25 and 771 thousandths are reasonably close, so the sum appears to be correct. Here they just went through and did the addition. 1, 2, plus 5 is 7. There's 9 plus 8 is 17. 4 plus 9 is 13. 15. 1 plus 1 is 2. Okay, number 1. Recall the situation in getting started. How many kilometers did Jenny actually run? So if we go back to that, getting started, I think I put it under here actually. Okay, so it wants to know how many kilometers she actually ran. So it wants us to add up these numbers. So if you need to use graph paper so that you can write in the boxes to keep your decimals in line, please do that. Feel free to grab a couple of pieces of graph paper to put in your binder. That way you'll have it whenever you need it. Make sure you hook it in. Don't just shove it in the pocket in the front, please. Okay, see how I kept my decimals in line? Some of the numbers from this table here on the left had 1 digit after the decimal point. Some had 2. So I'm just going to make sure they all look like they have 2. Remember, adding zeros, those trailing zeros at the end, does not change the value of the number. And then we'll add, we have 5, 10, 15. Carry a 1. 1 plus 7 is 8, plus 5 is 13. 15, 16, 16, and 6 is 22. Now, decimal points stay straight in line. 2 plus 4 is 6. 6 plus 5 is 11. 17, 19, 20. So 20 and 25 hundredths. So was that close? Was that close to our estimate? Remember, our estimate was 21. So our actual answer was 20 and 25 hundredths. So yes, it was close. A follow-up question I have, this is kilometers, which it didn't ask us, but I want to pose it, is she has a goal to run at least 25 kilometers each week. Did she meet her goal in this particular week? No, she didn't, because 20 and 25 hundredths is less than 25. Okay, so for these numbers, number 2, A, B, and C, you need to calculate the sum. That means you're just going to write them out, add them up. So there's not much room to write here. So I'm highly going to recommend you guys grab a piece of graph paper to write this on. I'm going to try to write it small. Remember, I need to line up the decimals. So I'll kind of put the decimal there and form the numbers in around it. I'm going to put a trailing 0 there, and then 7 3/100. If you can write small and you feel like you can keep things in alignment, then you don't need the graph paper. If you struggle with that organization, then get the graph paper. It will help so much. 8 plus 2 is 10. 0, carry a 1. Decimal point, stay straight in line. 7 plus 3 is 10. And then there's 6, so 16. 1 plus 1 is 2, so 26 8/8. You can hear my kitty Lily. She thinks she needs to eat yet again today, and she doesn't. So she's going to squawk at us for a while. Lily, get down. Okay. So 4, 3, 4, 7. The number 18. Where is the decimal point in the 18? It's at the end. Remember, like, we can say that you're 12 years old or you're 11 years old. We don't go around saying you're 11 or 12 decimal point, but that's truly what it means. I'm going to put the trailing zeros right in here. 130 and 6/10. I guess I better write this somewhere else. I do not have enough room. My apologies. Guess I better just move it over. And then 51 1/10. One goes after it. Okay, so see how nice and neat my columns are? You need to make sure that you're able to keep it lined up and neat. I'm going to put those trailing zeros in here. So 7 plus all those zeros, 7, 4, 3 plus 6 is 9 plus 1 is 10. Carry the 1. The decimal point stays in line. 5 plus 8 is 13, 14, 2, 5, 10, and 2. 204 and 47 thousandths is how that is read. Okay, pause the video, do number 3 on your own, be honest about it, and then come back and check your work, please. I'm actually going to pause the video as well. I'm going to fill it out so I'm saving time on the video. I will turn it back on momentarily. Okay, welcome back. So here is my answer. I hope yours matches. Please make sure that you line up your decimal points. Make sure that your numbers are nice and neat and that you can read them. You should have gotten 177 and 530 thousandths. And yes, you could have read that 177 and 53 hundredths, which would be the same thing. Okay, flipping it over, page 130. You can use a similar algorithm for subtracting decimals. Let's consider two different subtraction problems. 18 and 205 thousandths minus 3 and 91 hundredths. Estimating it, that's about 18. The 2 says to keep the same. The 9 says to make that 3 a 4. So 18 minus 4, 14. So our answer should be about 14. So then they wrote out the problem, lining up the decimals, put a 0 in, a trailing 0 here so that they had the same number of digits after the decimal point. Completed the subtraction as needed, got 14 and 295 thousandths. So is that close? So said first estimate, then line up the decimals so that like place values are in the same column, which is what they did, and subtract. Compare the answer to your estimate to check your work. So those are relatively close, so we think and assume that our answer is correct. The only way to know for sure is to check it with addition. I can literally just add kind of upright here. 5 plus 0 is 5. 9 plus 1 is 10. You put a 0 and carry a 1. 1 plus 2 is 3. 3 plus 9 is 12, which is that 2. Decimal point stays on line. 1 plus 4 is 5, plus 3 is 8, and we have a 1 plus 0. If you found that interesting, you've never seen that, or you have questions about what did she just do, let me know. We'll work through that. Okay, so yes, the estimate would be good, and I just double checked with addition. So 22 and 4 tenths would round to 22. 8 and 936 thousandths would round up to 9. 22 minus 9, our answer should be around 13. Then line up the decimals so that like place values are in the same column and subtract. So looking through that worked example, that's exactly what they've done. They lined it up. They added some trailing zeros here in the beginning. Now, you cannot, and I've seen so many kids doing this year. You can't do 0 minus 6. So many kids just want to flip it around and say, well, it's 6 minus 0 and put a 6 here. That is not correct. That is not correct. So you need to borrow or regroup so that you can have something in which to subtract the 6 from. There is nothing here, so this guy needs to go here. I'm going to do a quick little illustration. This is my little house story. This is your neighborhood block. Aren't my houses fantastic? Okay, so the rule on your block is when somebody's out of some type of food, let's say you're baking a cake and you need sugar. Okay, let's say you live in this house right here. The rule on your neighborhood street is you can only go to the person on your left to borrow sugar from. So this guy needs to go over here to borrow sugar. Hey, I need a cup of sugar. Do you have any? And this guy says, oh man, sorry, no, I don't. And then he says, hang on, let me go next door and check with Bob over there. Let's see if Bob has any. So he goes over here to this house, and Bob says, oh yes, here, I have some sugar for you. And he gives him the sugar, and then this guy can give it to this guy. So let me show you that here. Probably thinking, what on earth did she just say? Can you do 0 minus 6? No, you can't. So this guy can go next door to borrow. When he gets there, this guy's out of sugar. There's 0 sugar in his house. So this guy can go next door. He has 4 sugar. Yes, he can give him 1. Here he's giving him 1/10. So we change that 4 to a 3. And then that 0 becomes a 10. Now this guy has some sugar. So now this guy can say, hey, can I have some sugar? Can I borrow some? He's like, yeah, sure. So he takes this 10 and he subtracts off a unit of sugar. Here he's doing hundredths, and he gives it to the neighbor who now has 10. Now you can do 10 minus 6, which is 4. 9 minus 3, 6. 3 minus 9, you can't do. The rule on the block, you can go next door. This guy has some. So the 2 becomes a 1. This 3 is then a 13. I'm just going to put the 1 right in front of it. It just became a 13. 13, which is what they did here as well. 13 minus 9 is 4. Decimal stays in line. You can't do 1 minus 8. This guy can go next door. That 2 can become a 1, and this 1 is then an 11. 11 minus 8 is 3. 1 minus nothing is 1. Okay, number 3 says, recall the situation in the getting started. If Jenny ran 20 and 2500 kilometers, how many more kilometers does she need to run to reach her goal of 25 kilometers this week? Excuse me, I had to yawn. Okay, so when we need to know how many more, that's going to be a subtraction problem. So she wanted to run 25 kilometers. She only ran 20 and 2500. So if we want to know how many more, we're going to subtract these two numbers. And this is just a whole number. I don't have any decimal point there. The decimal point is one of those invisible things in math. Remember, it's at the end of a whole number. Then I can put those trailing zeros in there because it does not change. The number 25 and 25.00 is still 25. Okay, let's subtract. 0 minus 5. This guy can't do that. He's going to go next door. Nothing to borrow there. This guy will go next door. Okay, the 5 becomes a 4. That 0 is now a 10. And now this guy can come next door. So that 10 becomes a 9. And now that 0 is a 10. Now we have 10 minus 5, which is 5. 9 minus 2 is 7. Decimal point stays in line. 4 minus 0 is 4. 2 minus 2 is 0. We don't need to write that. So she needs to run 475 hundredths more kilometers. Okay, number 4 says calculate each difference. I'm going to do 4A with you, and then I would like you to pause and see if you can do B and C. So, trying to figure out where I want to write this to give myself some room. Guess I'm going to put it right here. 459. Actually, I'm going to move it down some. Again, you should probably use some graph paper. If I had some here at home, I would be using it. 459 and 6/10 minus 12 and 43 hundredths. Okay, let's put a 0 in there, trailing 0. I can't do 0 minus 3. So this guy goes next door. He's got something to share. The 6 becomes a 5. That 0 is now a 10. Now I can subtract. 10 minus 3 is 7. 5 minus 4 I can do. That's 1. Decimal point stays in line. 9 minus 2 is 7. 5 minus 1 is 4. 4 minus nothing is 4. So there's your answer. Please hit pause, finish those problems, and then come back and check them. Okay, so welcome back. So I forgot we should always kind of estimate first to see if our answer is in the ballpark where it should be. So 68 and 998 thousandths. If we're looking at the nearest whole number, that 9 says to make that 8 a 9, so 69. This is 9 and 9/10, so that 9 tells us to make that a 10. So 69 minus 10, our answer should be around 59. I did in fact get 59 and 98 thousandths. In letter C, we have 17. The 4 says to keep the 7 the same. And in this one, the 2 says to keep the 3 the same. So we have essentially 17 minus 3, which is 14. And my answer did in fact align with that. I hope you did well, and I'll see you on the next video.